Hola amigos, bienvenidos. Welcome to the brand new series of VFD tutorials. This is the first video. I will show you examples with block diagrams, images, etc. With that said, what's up guys, Nadi here, and without any further ado, let's get started. Now, what's happening inside of a drive? Okay, there are three main power sections in the VFD. There is the converter section, DC bus section, and the inverter section. So a lot of people just call it a drive or inverter. Why we have these sections is because we are converting a constant frequency and voltage to a variable frequency and voltage. Okay, the purpose is it allows us to control the motor speed and torque. Now the whole circuit, the components, the RST or L1, L2, L3, that's your supply input 3-phase, and we are rectifying the AC to DC, then again to AC. Now let's look at the converter section. Now if this is made up of diodes, and if you look, it is made up of 6 diodes. This is a 6 pulse drive, 2 pulse for each phase, negative and positive, and we use a rectifier module like this. Now the DC bus section. This section has 2, 4 or more capacitors dependent on the kilowatt of the VFD and the model. This is the AC waveform and this is the unfiltered DC waveform. And this green line shows the waveform after the capacitor bank. Technically, the more capacitor and the more pulse, say 12 pulse drive, the smoother the DC. About the DC bus section. Here we have a soft charge or pre-charge circuit which has a resistor and a contactor. These protect your capacitors and rectifier because electrically capacitors are seen as a short. So this circuit is going to resist any inrush current to the capacitors and slowly charge it up to a minimum low level point. Then the contactor operates and closes the circuit and it is completed. And most of the drives are going to have a fuse for IGBT protection. Next is the inverter section. It is made up of IGBTs, insulated gate bipolar transistors. Drives don't actually create a sinusoidal output, they are pulse width modulation (PWM) outputs, and they replicate the sinusoidal output. The current waveform is in the sinusoidal form, so the motor runs. In VFDs, we don't have to use external overload protection circuit because these are inbuilt in the VFD. When using multiple motors at VFD output, we have to use this formula for current setting. In VFDs, the power on-off cycling limit should be maximum 2 times per minute, or the pre-charge section can get damaged. Derating of VFDs. We use a 3-phase choke for input harmonics reduction and protection from stray voltages, spikes and transients, which can damage the VFD. Long cable distance from the VFD to the motor greater than 30 meters and the heavy loads etc. can induce current spikes in the motor, as the cable acts as an amplifier and increases the current spikes, and it can damage the VFDs. So we use an output choke. So guys, that's all for today for this quick briefing of the VFD. Make sure to subscribe so you don't miss out on my future videos. Wait for the in-depth videos coming soon. Take care guys, see you in my next video. Jai Hind, Vande Mataram.